All right, welcome to another deep dive. Today, we're going to be taking a look at the brain, and we're going to be doing that with this book that you guys sent to us. Deshuya.
That translates pretty directly as brain ripping, debunking brain pseudoscience.
Yeah. So right off the bat, we get a feel for what the author is going for here.
It's clear that they feel a real empathy for the brain, observing how it's constantly bombarded with what they call unser and he. So seemingly true, but actually false. Kind of like fairy tales and rumors about the brain.
Yeah.
There's a real drive to clarify things for this incredible but often misunderstood organ.
Absolutely. So what we want to do today is to take a look at some of these widespread brain myths. And we're going to use the insights from these excerpts that you guys sent over. And our goal here is to try and find those like kind of aha moments, those like surprising but true things about the brain that will stick with you. And we want to do this without getting too like bogged down in all the super technical scientific stuff.
Keep it approachable.
Keep it approachable. Exactly.
Sure.
So the first one that really jumped out at me was this whole idea of brain reading with scanners.
Yeah.
You see it all over, these big splashy headlines in the news. I know you're thinking brain scan, a huge leap forward in understanding thought.
Yeah, it's kind of like, it's a really captivating thought, right? Like you could just use technology to look directly into someone's mind.
Right.
The book mentions things like fMRI, so functional magnetic resonance imaging, and EEG, electroencephalography, incredibly advanced sounding names that can easily lead people to believe that we're just about there.
Yeah, it sounds like straight out of a sci-fi movie.
Right.
Like you're going to get hooked up to this thing and they're going to know your deepest, darkest secrets.
Absolutely.
But as the book clarifies, like the reality is a little bit different.
It's far more complicated.
Yeah.
So when we talk about trying to measure brain activity, we're dealing with incredibly faint electrical signals from individual neurons.
Yeah.
And when you consider that there are about 80 billion of those in the human brain,
Right.
trying to measure that directly is like trying to listen to a single conversation in a stadium full of people all talking at once.
I've been to a few concerts like that.
Yeah.
I can only imagine how difficult that would be.
Absolutely. So EEG, which the book really cleverly describes as kind of beachy sing. So essentially eavesdropping on the brain's cheering songs. It's like that general roar of the crowd.
Right.
It does pick up on this collective electrical activity of, large groups of neurons.
Right.
And this is very useful, right? It gives us real-time monitoring, which is why it's used in things like sleep studies or for detecting seizures.
Right.
However, actually pinpointing where in the brain a thought originates from, or even harder, like what its content is incredibly difficult.
Yeah.
So the localization of the signal isn't really that precise.
And then we have fMRI, which is what produces those like, really kind of colorful brain scans that you see.
Right, the ones you see in all the articles, yeah.
And the book makes it really clear that fMRI isn't measuring thoughts directly.
No, not at all. It's not like we can just, point to a little glowing spot and say, aha, that's where they're thinking about their grocery list.
Right. So what is it measuring then? What's going on?
What's really interesting is that fMRI primarily measures water.
Okay.
Specifically the hydrogen atoms in water molecules, and more importantly, changes in blood flow, or A, as the text puts it.
Blood flow, okay.
Yeah, the idea is that areas with more neural activity will need more energy, and that leads to increased blood flow.
Right.
So those vibrant or colorful brain maps that we see, they're indirect representations. They're created by computers that process and color code differences in blood flow over time.
So instead of seeing each individual car and knowing where it's going, it's more like looking at traffic patterns from above.
Exactly, yeah. You can tell where there's congestion, where things are moving faster, but you don't actually know what's inside each vehicle.
Right. And then there's also the speed of this whole process, right? Like the book mentions it takes so nearly 2 seconds to get a single image.
Yeah, which doesn't sound like a lot, but...
Which seems fast in our world.
In our world, yeah.
But compared to the speed of thought, that's a lifetime.
Exactly. Compare that to the speed of neural impulses, which can travel at USU, so 400 kilometers per hour.
Wow.
It's a huge difference. The author uses this like fantastic analogy, comparing it to taking photos at a Formula One race, but only every 2 seconds.
Oh, okay.
You might get some, interesting abstract shots, but you'd miss the real action, the moment-to-moment decisions and reactions of the drivers. So the key takeaway here isn't that these brain scans are useless, not at all.
Right.
But they offer this very indirect and time-delayed glimpse into brain activity, far, far removed from the instantaneity and complexity of thought itself.
Right. That makes a lot of sense. And it's not like the scanner just magically lights up whenever, a brain is thinking.
Yeah.
There's a really important step of calibration that's involved. And they even give this example with Florian Silberazin in the book.
Yeah. So what's really fascinating about fMRI studies is how they often measure the difference in brain activity between two different states or when someone is performing a specific task.
Okay.
So in this Florian Silberazin example, the researchers would likely compare brain activity when someone is looking at, say, a blank screen versus when they are shown a picture of the celebrity.
Right.
And the areas that show increased activity when viewing the picture are then labeled as, involved in processing that image. But we're not actually seeing, the thought of Florian Silberazin.
Yeah.
We don't actually know for sure what the person is thinking or feeling.
Right.
They might recognize him, they might not. They might be thinking about something completely different.
They might have just spaced out for a second.
Exactly. So it's not as straightforward as, seeing a thought directly.
Right. Yeah. It's just showing us that there's a difference in activity, but not the thought itself.
Absolutely.
And those colorful areas that we see on the scans, those aren't the only parts of the brain that are active.
Exactly. The book really emphasizes this. It's more about highlighting the differences in activity levels. All those gray areas in the fMRI images, those are still working parts of the brain.
Right. They don't just go dark.
Exactly. And those bright colors are artificially added to make these subtle differences in blood flow more visible. Otherwise, the whole scan would look like, a fairly uniform gray blob.
Right. And then it becomes even more abstract when you consider that fMRI studies often average the results across many different people's brains, right?
That's right. It's essentially creating this, statistical composite general trend across a group of individuals.
Right.
And while this can reveal important overall patterns, it doesn't necessarily reflect the unique activity patterns of any single person.
Right. So it's not really a picture of your brain or my brain. It's more like a generalized map.
Yeah, like an average brain, whatever that might be.
Yeah, exactly. And then taking this from these very controlled lab settings to real-world situations, like they talk about neuromarketing, it just seems like a huge leap of faith, right?
It does, doesn't it? I mean, lying perfectly still inside a giant machine with your head immobilized isn't exactly how most of us make decisions when we're out shopping or, living our daily lives.
Right. If I'm stuck in an fMRI machine, I'm probably not thinking about what brand of cereal I want to buy.
Probably not, no.
I'm probably thinking about how I want to get out of this tube.
Exactly.
So there's this big disconnect between the controlled environment of the experiment and the messy real world where we actually make these choices.
Yeah, it brings up this really important point about how well these controlled experiments, as fascinating as they are, actually reflect real-life behavior.
Right. And then the book also mentions this idea of the Beal guy, or the voxel.
Right, the voxel.
And that's the unit of measurement, right?
Yeah. And what's really mind-boggling is that each voxel is about the size of a pinhead.
Yeah, they said the size of a pinhead. And that sounds incredibly small.
It is.
But then they go on to say that within just one of those tiny voxels, there could be at least 500,000 neurons and 5 billion synapses.
It's an incredible amount of complexity packed into that minuscule space.
Yeah. So when we see that an fMRI scan lights up in a particular spot, it's not really telling us a simple story.
It's representing the average activity of this incredibly complex microscopic world.
Right. So the big takeaway here, I guess, is that despite all those, kind of eye-catching headlines, we can't currently read minds with brain scanners.
Absolutely not.
Instead, as the book says, we observe the thinking brain, but by measuring these sort of indirect signs like blood flow and energy changes.
Right. It's more like watching the shadows on a wall than seeing the actual puppet show.
I love that analogy. Okay, let's move on to another myth that I think is really interesting.
Okay.
This whole idea of the triune brain.
Right.
This notion that there's this primitive reptilian brain that's constantly battling it out with our more rational higher brain.
Yeah. I mean, this idea is really popular, right?
Yeah, it's everywhere.
And it's really easy to grasp, right? This idea that the this reptilian brain or brainstem, is responsible for our most basic instincts, like our fight or flight response, our aggression, our territoriality, our, desire for food and sex.
Yeah, it's like the lizard brain taking over.
Exactly. And then, of course, we have the buo, the rational brain, that handles things like planning, decision-making, higher-level thinking, moral reasoning.
Right, so like this constant tug of war between the primal and the civilized.
Exactly. And the book even gives some funny examples, like men watching football or women choosing shoes.
So those are examples of the reptilian brain taking over.
Supposedly, yes. The idea is that when we're engaged in activities that are seen as, less intellectual, our inner lizard takes over.
Right. But the book really pushes back on that.
Yeah, it does. And it does it in a really interesting way.
Okay.
It challenges the very definition of what primitive even means in an evolutionary context.
Yeah. And that makes sense.
Yeah.
Because we throw that word around a lot, primitive.
We do.
Yeah.
do. And we often use it in a way that implies simple or undeveloped.
Right, like something's not as good.
Exactly. But the book really emphasizes that in evolutionary terms, kias, or primitive, doesn't mean simple, it means earliest.
Okay.
It's about the order in which these structures evolved, not a judgment on their complexity or sophistication.
Gotcha.
They even use this really good analogy of towels on a pool chair.
Oh, I'm intrigued. Tell me about this analogy.
So imagine you're at a pool and you're trying to claim a lounge chair. The first towel that gets thrown down, that one is eat up.
It was there first.
It was there first, it got the spot.
I like that.
The towels that come later they're later developments, but they're not necessarily any better or worse than the first towel.
That's a really good analogy, and I think that's a really helpful way to reframe how we think about those, kind of quote-unquote more primitive parts of our brain.
Yeah, because it's not about being better or worse. It's about being foundational.
Right.
It's about being essential.
Right. It's at the base layer.
Yeah.
So if we're not talking about a separate, lizard brain that's making us do all these, kind of instinctive things.
Yeah.
What are we really talking about when we say reptilian brain?
Right. So the reptilian brain, isn't actually this distinct anatomical entity, right?
Okay.
It's not like a separate little brain within our brain.
Okay.
Instead, it's a collection of brain parts, mainly what we call the brainstem,
Okay. The brain
that controls vital life-sustaining functions.
Okay.
The book describes it as the brain's so the water and electricity general manager.
Okay.
Right. It connects the spinal cord to the rest of the brain and regulates essential processes. We're talking breathing, swallowing reflexes, eye movement, balance, all that good stuff.
So less about primitive, instinctive behaviors.
Less about that, yeah.
More about keeping us alive, the fundamentals.
Absolutely. Keeping the lights on. It's more like, the essential operating system, not a separate entity dictating our impulsive behaviors.
Right. And then this idea that all higher cognitive functions are located solely in this, rational brain, that also seems like a simplification.
It is a simplification. The book points out that instinct and reason often involve the same brain areas working together.
Right.
It's not this, either-or situation,
Yeah.
right? It's not like one part of the brain switches off when the other takes over.
We're not just flipping a switch between our lizard brain and our, our human brain.
Exactly. And furthermore, the text introduces this really interesting concept of the O, or dicephalon, which acts like they call it central secretariat.
Right.
So this area actually filters sensory information, everything except smell, before it reaches the cerebrum.
Okay.
And it plays a crucial role in regulating things like body temperature, water content, hunger, not exactly primitive functions.
No, that's pretty sophisticated stuff.
Absolutely. So it's not this simple dichotomy of, a primitive brain being overridden by a rational brain.
Right.
It's a much more integrated and collaborative process than that.
Right. It really does highlight that the brain is much more interconnected than, this simplistic triune brain model would suggest.
Absolutely.
Okay. Let's move on to our third myth.
Okay.
This idea of a modular brain, where we have specialized centers for absolutely everything.
Right. The brain as a collection of dedicated centers.
Because you've got your, math center over here.
Math center.
You've got your fear center over there.
Your fear center in the back.
You've got, your creativity center in the
Your
front.
language center over here.
Exactly. And this is really appealing, right?
It is. It's this, or analogy, right? The brain as a set of drawers or modules, each with a very specific function.
Right, like little apps on your phone.
Exactly.
You open up the language app when you need to speak, or you open up the math app when you need to do some calculations.
Absolutely.
And the book even mentions how this gets reflected in kind of like media reporting, where they'll talk about the math center.
Right. So there might be research that identifies a brain region involved in, number recognition, and suddenly it's splashed across headlines as the math center.
Right, because it's catchy, it's simple.
It's simple, it's memorable.
But as the book points out, this idea has a really interesting history, tracing back to phrenology.
Oh, yes. Phrenology. That's a fun one.
Which is not exactly known for its scientific rigor.
No, not really. But it's fascinating from a historical perspective. So back in the 18th century, you had this guy named Franz Joseph Gall, and he proposed that the size of different brain regions, which he believed could be determined by feeling the bumps on someone's skull, actually corresponded to specific personality traits and abilities.
So if you had a bump in a certain spot, you were more likely to be, musical or mathematical or whatever.
Exactly. And while this has, of course, been completely debunked, it's interesting how this early notion of very localized brain functions has kind of lingered in the popular imagination and still influences how we sometimes talk about the brain.
Yeah, it makes sense, though, because it's a lot easier to grasp than like a complex interconnected network, right?
Absolutely. We understand organs like the heart with its chambers or the lungs with their lobes.
Right. Those are very distinct, kind of physical structures.
Exactly. So maybe we try to apply the same kind of thinking to the brain. But the brain's functions aren't as visually obvious, It's this like soft, interconnected tissue, and understanding how it works requires a lot more than just looking at its structure.
Right. So moving on from phrenology, the book talks about Brodmann's areas.
Oh, yeah, Brodmann's areas.
And those are, more scientifically grounded attempts at brain mapping.
Right. Brodmann, in the early 20th century, meticulously mapped the cortex into 52 distinct areas.
Right. And we sometimes see those on brain diagrams with all those numbers.
Yeah, exactly. All those numbered areas that you see.
Right. And his work was based on, cytoarchitecture.
That's it. Cytoarchitecture.
Huh.
So basically, the cellular organization of different brain regions.
Right, looking at the different types of cells.
Exactly. He was looking at how the cells were arranged and layered in different parts of the cortex.
So it's based on actual physical structure rather than, bumps on the head.
Exactly. It was much more detailed and scientific. And then later, functional correlations were added based on, what happened when people had damage to specific areas.
Oh, like Broca's area, right?
Exactly. So Broca's area, which is linked to speech production.
Right.
And Wernicke's area, which is associated with language comprehension.
Right. If you have damage to those areas, you have problems speaking or understanding language.
Precisely. And these findings did suggest that, yes, there is some degree of modularity, particularly in more basic sensory and motor processing.
Right. So, there's some validity to this idea.
There is.
But it doesn't really go as far as we sometimes think it does.
Right. The book argues that this kind of strict modularity doesn't really extend to more complex functions like emotions, personality, creativity, those sorts of things. It criticizes those fMRI studies that try to pin down very specific centers for these complex functions.
Because it's just way more complicated than that.
It is. And it reminds us of the inherent limitations of the method, right?
Yeah.
It's slow, it's indirect, and there's always a temptation to overinterpret those colorful images.
Right. Because we want to believe that it's that simple, that there's a little spot in our brain that's responsible for, making us love music or something.
Exactly. And the book uses this great example of the psi, or the amygdala, which is often labeled as the fear center.
Yeah, we've all heard about the amygdala.
We have. It's very popular. But it's not just about fear. It's involved in much more than that.
Okay. So what else does it do?
Research has shown that it plays a role in things like the anticipation of profit.
Really?
Mm-hmm. Our response to emotional music.
Interesting.
And even our reaction to smiling faces.
Okay. So just because you see activity in the amygdala doesn't mean that someone's terrified.
Exactly. They could be excited about winning money. They could be moved by a beautiful song.
Or just happy to see a friend.
Exactly.
Yeah.
So it's not as simple as, one area, one emotion.
Right. And it also highlights how oversimplified it is to just pin, these complex emotions down to a single region.
Absolutely. The book emphasizes that emotions arise from the coordinated activity of the TCM, so the cerebrum, diencephalon, and other parts of the limbic system.
So it's like an orchestra, not a solo performance.
Exactly. You need all those different instruments working together to create the overall experience.
I like that. Okay, let's move on to our fourth myth.
Oh.
The idea of left brain versus right brain dominance.
Oh, yeah. The left brain, right brain. This is a classic.
This is a classic. You see those online quizzes everywhere. Are you left-brained or right-brained?
Constantly. And it's really taken hold in the popular imagination, hasn't it? This idea that, people are either logical and analytical or creative and intuitive.
Right. And it's used to explain, like, why someone might be good at math or why someone might be good at art.
Exactly. It's like, oh, well, she's a writer, so she must be right-brained.
Right. She must be using that creative side of her brain. And the book points out that this has actually spawned a whole industry, right?
It has. An entire industry of self-help guides and apps that promise to unlock your hidden potential by, tapping into your so-called dominant hemisphere.
Yeah, like unleash your right brain.
Exactly.
It's really appealingly simple, right?
It is. It is.
But, as the book points out, the reality is far more nuanced than that. And they do acknowledge that, anatomically, we do have two hemispheres.
Yes, and they're not perfectly symmetrical in their functions.
Right. So there is some truth to this idea that the two sides of our brain aren't exactly the same.
Absolutely. There are some functional lateralizations.
Like, what's an example of that?
For example, language centers tend to be predominantly in the left hemisphere for most people.
Okay.
And each hemisphere controls the opposite side of the body.
Right. So the left side of your brain controls the right side of your body.
Exactly. But it's a huge oversimplification to say that one hemisphere is solely responsible for logic and the other for creativity.
Right. So we're not just split right down the middle.
No, not at all. And the book highlights this really important structure called the corpus callosum, the shade.
Okay.
It's this massive bundle of nerve fibers. We're talking about 250 million nerve fibers connecting the two hemispheres.
So they're constantly talking to each other.
Constantly, yeah. It's like a superhighway of information flow between the two sides.
Okay. But what about those studies where they actually severed the corpus callosum, the split brain studies?
Oh, yes. Those were groundbreaking, pioneered by, Roger Sperry and Michael Gazzaniga.
Right.
They did reveal some really interesting things about what happens when those two hemispheres are disconnected.
Right.
They showed that, when the hemispheres are disconnected, each one can actually function somewhat independently.
Wow.
And they have different specializations.
Okay.
So, for example, if you showed an object to the right visual field, the left hemisphere could typically name it.
Okay.
But the right hemisphere, because it lacked those dominant language centers, it could only identify it by touch.
Okay.
But not verbally.
Interesting.
So it was like having two separate entities.
Wow.
But the book cautions against taking those findings and applying them too broadly to, personality types.
Right. So just because you're good at language doesn't mean you're left-brained. And just because you're good at, spatial tasks doesn't mean you're right-brained.
Exactly. It's way more complex than that. The split brain studies are fascinating, don't get me wrong.
Yeah.
But it's a huge leap to apply those findings to everyday behavior. The book directly challenges the idea that one hemisphere is always in charge, and they use this great example of dancing. So they talk about different types of dance, like a classical waltz versus free dance.
Okay.
And they found that these different types of dance activate different brain patterns, with free dance actually showing a significant involvement of both hemispheres.
Okay. So both sides are working together.
Working together, yeah. And it's not just about logic versus creativity. Even things like math, which we traditionally think of as left-brained, actually involve collaboration between the two hemispheres.
Right. So there's no such thing as a purely left-brained or right-brained thinker.
Exactly. It's a myth. As the book concludes, the brain functions as this integrated unit. It's this constant communication going on between the two hemispheres.
Right. Right. Okay, let's move on to our next myth. The idea that a bigger brain must equal more intelligence.
Ah, yes. Size matters, right?
Right. I mean, it seems intuitive, right?
It does. It's like saying, well, a V16 engine has more power than a three-cylinder engine, so surely a bigger brain means more processing power, more intelligence.
Right, right. And the book even mentions this, kind of common but problematic comparison between men's and women's brains, right? Men's brains tend to be slightly larger, but that doesn't necessarily mean anything about intelligence.
Exactly, exactly. And when you start to look across the animal kingdom, the relationship between brain size and intelligence becomes much, much less clear.
Right. Like humans, we have pretty big brains, but we don't have the biggest brains in the animal kingdom, right?
Not even close. Whales, for example, have brains that are considerably larger than ours.
Right, right. So if it was just about size, whales would be ruling the world.
Exactly. But absolute brain size alone doesn't perfectly correlate with what we understand as intelligence.
Right. So a whale's brain is massive, but a lot of that brain power is dedicated to, controlling this huge body and processing all the sensory information from living in the ocean.
Absolutely. It's a different kind of intelligence. So scientists have tried to refine this comparison by looking at things like the brain-to-body weight ratio.
Okay.
And the encephalization quotient, or the SANARI.
Which takes into account, the size of the animal's body.
Exactly. How much brain do you have relative to how much body you have?
Okay.
And even when we look at these ratios, we get some surprising results. Like, the book mentions that a shrew actually has a higher brain-to-body weight ratio than a human.
A shrew.